Hi, I'm Coke Smith, and I teach ESS, and that's Environmental Systems and Societies, at the International School of Bangkok. We're on a class trip here in the Chiang Mai region of northern Thailand. Today, the students will be conducting fieldwork that they previously designed in an effort to complete and collect data for their IAs. I think you can't truly have an environmental systems course without getting out into the field. There's no more valuable experience. The kids are in the field, they're actually experiencing what we've talked about in class firsthand, and they're learning in a real sense, in an authentic sense, how complex even a simple orchard jungle situation like this is.
Before starting their fieldwork activity, each student must ensure they have developed a coherent and focused research question that is relevant to issues encountered in the Environmental Systems and Societies course.
Can you catch us up on what you're planning on doing?
I'm investigating the correlation between human structures and the level of dissolved oxygen of an ecosystem.
I'm investigating the correlation between the depth of the river and the variety of macroinvertebrates present.
My research question is what is the correlation between the pH level and water turbidity towards the abundance of macroinvertebrates?
The kids have had some practice, albeit about 2 months ago. But I think when planning for a field experience like this, it's really, really important to make sure the kids have a little bit of expertise prior to coming out. All they really have to do out here is kind of analyze the new situation and figure out how what they've learned in class can be applied to this unfamiliar environment.
Once the research question has been established, students choose the techniques and apparatus that will allow them to collect sufficient data that is relevant to their question.
So what is that device you're going to be using? Could you let us know that?
I'll be using multi-parameters to measure the DO level, and I'll be also using a velocity stick and temperature probe to measure velocity and temperature, so that I can also check whether those two also influence the DO level.
I'm focusing mainly with the turbidity tube.
For measuring the macroinvertebrates, I'm going to be using the kicknet test.
Okay, kicknet test, great.
This is a quadrant, and you randomly place this quadrant to measure the % coverage of plant species.
Okay, fantastic.
In fieldwork, students must also choose their sampling strategy. This could be random or could be representative. For example, collecting from a specific cross-section of the available data. The choice depends on the nature of the research question and the practical limitations that the students may encounter. Collecting data in the field can be challenging, and an extra pair of hands can be helpful. However, for the individual investigation, students must have their own data, and so the same data cannot be used by different students.
Even though we have different research objectives, we each have to get trials done, so we kind of help each other make sure that we are going along a consistent gradient when collecting our data, and it's also good to get different varieties of locations.
Fieldwork often gives rise to unexpected challenges. Students will respond to these challenges and will adjust their methodology accordingly.
So what if you guys are out in the field and you're doing your studies and you don't find what you're expecting? Is that okay? Yeah, I mean, the data doesn't always point in the direction you expect it to, and that's okay. So are you starting to see any trends so far?
I was looking at dissolved oxygen, and I was thinking if the velocity is higher, it's churning the water more. That's higher dissolved oxygen, therefore there would be higher macroinvertebrates. That's what I had in my head. But it seems as though directly after, where it's faster flowing, where it stagnates a little bit but not too much, that's where they are.
the most are.
I was very pleased with how the students adjusted their practices to suit the field conditions. One particular example would be like with the turbidity tube. The students who were doing that, it's one thing to collect it in a still pond in one location to another. But here we had students upstream disrupting the turbidity, and the students had to note that and adjust their positioning accordingly.
When we first started using the kicknet, when we were shoveling in the dirt.
A lot of dirt.
Yeah.
You collected a whole lot of dirt.
Yeah.
Right? So you adjusted some of your strategies.
Yes.
Right. Yeah. Prior to the field experience, I had certain goals and objectives that I wanted to accomplish. And as the experience progressed, I can honestly say that the students have met those objectives. A lot of them are, instead of coming up to me and asking for the solution, they're talking to each other like colleagues would do. And that's, to me, the epitome of the field experience. When kids could get together, collaborate, work together, solve the problems they're encountering in the field, and actually determine what kind of alterations they have to make in their protocol to come up with a really good study.